When you're shopping for a new gaming mouse, then you will notice the insanely high DPI values supported by current sensors. But while the sensor can go up to 20,000 DPI or even more, many players have their mouse set to just 400 DPI or even less for various reasons. So how does the DPI setting affect your gaming experience? And more importantly, does it have an impact on the input lag of your mouse? If you have ever played around with different DPI values, then you know that it affects how strongly an application responds to your input. Here I have restricted how far I can move my mouse to the left and to the right. At 100 DPI my character doesn't move very far when I move my mouse. When I increase the DPI value from 100 to 400, then moving my mouse over the same distance causes a stronger response, which increases further when I set it to 1600 DPI. So when you increase the DPI value, you increase the sensitivity of the sensor which tracks the movement of your mouse, which then causes the game to have a stronger response to your input. But how much or even if that affects the input lag of your mouse has been a hot topic for many years. So to answer this question, I used one of my special input lag testing machines, which you can find out more about in the video I link to in the description. For the first test I had the linear solenoid push the plate below the mouse at the slowest speed possible, which meant that from a standstill it took the plate 99 milliseconds to travel the first 10 millimeters. Even though this is the slowest speed I can get with my linear solenoid, it is not that slow when you look at it in real time. In fact, while gaming, you will find yourself moving your mouse even slower than that. Now, with the monitor set to 144 Hz and the LDAT display test software running at 144 frames per second, I measured an average system latency of 42.72 milliseconds with the Razer DeathAdder V2 Pro set to 100 DPI. At 200 DPI, the system latency was 10 milliseconds lower. When I doubled the DPI value again to 400, the system latency was reduced by another 6 milliseconds. Doubling it again to 800 DPI led to 3 milliseconds less lag. But doubling the DPI value 2 more times showed diminishing results. That said, by simply increasing the DPI setting from 100 to 1600, I could cut the system latency in half. When I then connect the average delays, you can see how the input lag is affected by the DPI value. The results also show that, at a specific speed, there is a limit where increasing the DPI value further does not result in a noticeable delay reduction. Now, what happens when I have the linear solenoid push the plate as fast as it can? Which means that it will move about 3 times faster and only need 31 milliseconds to travel the first 10 millimeters. That speed is quite fast, as you can see when you look at it in real time. I suppose this speed qualifies as a so-called flickshot. So when I push the plate with the slowest speed possible, I measured 21.59 milliseconds on average at 1600 DPI. But when I pushed it as fast as I can, I measured 22.48 milliseconds on average at 100 DPI. Doubling the DPI value 5 times while having the mouse move at that fast speed only had a very small impact on the measured system latency. So the speed at which you move your mouse is a very important factor when it comes to how the selected DPI value affects the input lag of your mouse. When you do a flick shot, then the selected DPI value has a very small impact on the input lag of your mouse because of how fast you move it. That said, how accuracy is affected by the DPI setting is an entirely different topic, which I'm not looking into in today's video. Now, most of the time you don't do a flick shot, you move your mouse slower. Much slower in fact than what I used for my slow speed test. Going back to having the mouse move at a slower speed, with the monitor's refresh rate set to 360 Hz and the LDAT display test software running at 500 frames per second, we can see that the delays are lower than before at 144 Hz and 144 FPS. But at that speed we again see that the input lag of the mouse is strongly affected by the selected DPI value. However, when I send the mouse flying across the desk, the DPI value again has a minor impact on the delays. So, based on my tests, it is clear that the selected DPI value has an impact on the end-to-end latency that you are subjected to. The slower you move the mouse, the stronger the delay is affected by the selected DPI value. And as I said, the slow speed I tested with is still faster than what you will move your mouse at while you are, in example, tracking an enemy. And if I could move the mouse slower in my tests, then we would also see DPI values of 3200 and more have a stronger impact on the delays, which then provides an argument to use DPI values greater than 3200 to reduce system latency. Again, I focused on system latency in my video, not accuracy, which, depending on the quality of the mouse sensor, might be an additional argument for using even higher DPI values. So I do not want to tell you what DPI setting you should use, nor do I dare to declare a specific DPI value to be the ultimate value everyone should use. But let's say that based on the data I provided, you want to increase the DPI setting on your mouse to 800 or 1600, which seem like reasonable default values. If you do not like how strong a game responds to a higher DPI value, then you can tone it down by adjusting the sensitivity in-game. But the DPI value does not just affect games, it also affects the mouse cursor on the Windows desktop. Luckily, you can adjust that as well. However, if you find that the sensitivity option in a certain game or the one in Windows doesn't give you the desired result, then most mice support DPI profiles or stages you can switch between. So you could have one stage set to 400 DPI, which you use on the Windows desktop, and another set to like 1600 DPI that you switch to for gaming. Most mice also allow you to use a button to switch between different DPI values. So switching between like 400 and 1600 DPI can be done on the fly. Well, and that's it for today. Shout out to my awesome patrons who keep my channel alive with their support. If you would like to join them, then you can find a link to my Patreon in the description down below. If you enjoyed this video, then please give it a like, subscribe for more, ring the bell to get notified when I upload my next video, and I hope to see you next time. Until then, have a nice day and take care. My name is Chris, and this was Battle Nonsense.